Welcome to the session on circles and straight lines. In this session, we will be looking at intersections of straight lines and circles. The objectives for this session are to find the number of intersection points of a circle and a straight line by finding the discriminant of the resulting quadratic equation. A straight line can intersect a circle 0 times, as shown in the illustration, or once, or twice, as shown. We can find the number of times a straight line crosses a circle in the following steps. Substitute the equation of the line in the equation of a circle to obtain a quadratic. Then find the discriminant b squared minus 4ac in the quadratic, ax squared plus bx plus c equals 0. If b squared minus 4ac is less than 0, then we have 0 real roots. In other words, there are 0 points of intersection between the line and the circle. If b squared minus 4ac equals 0, then we have 1 real root, in other words, 1 point of intersection. And if b squared minus 4ac is greater than 0, then we have 2 real roots, in other words, 2 points of intersection. Let's now have a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. The example states, show that the line y equals x plus 2 meets the circle x minus 1 all squared plus y minus 4 all squared equals 25 2 times and find the coordinates. So let's solve this. If we substitute the equation of the line in the equation of the circle, as shown, then we obtain x minus 1 all squared plus x minus 2 all squared equals 25. Expanding, x minus 1 all squared gives us x squared minus 2x plus 1. And expanding x minus 2 all squared gives x squared minus 4x plus 4. And of course 25 remains as it is. Then tidying up gives us 2x squared minus 6x minus 20 equals 0. As shown. Finally, dividing by 2 gives x squared minus 3x minus 10 equals 0. In order to find the number of roots of this equation, consider the discriminant b squared minus 4ac. This equals minus 3 squared, which is 9, minus 4ac, which is 4 times 1 times minus 10. This equals 49. Now, since the discriminant is greater than 0, there are 2 solutions, and therefore the line meets the circle twice. As shown. We will now find the 2 points of intersection. Applying the quadratic formula to 1x squared minus 3x minus 10 equals 0 gives x equals minus minus 3, which is plus 3, plus minus the square root of minus 3 squared, which is b squared, minus 4ac, which is minus 4 times 1 times minus 10, all over 2a, which is 2 times 1, This simplifies to x equals 3 plus or minus root of 49 all over 2. And of course, square root of 49 is 7. So x equals plus 5 or minus 2. Therefore, the 2 points of intersection occur at x equals 5 or x equals minus 2. When x equals 5, y is equal to x plus 2, which equals 7. By substituting x equals 5 in the equation of the line. Similarly, we can find the y value when x equals minus 2. Again, substituting in y equals x plus 2 gives us that y equals 0. Therefore, the points of intersection are 5, 7 and minus 2, 0. As shown. This brings us to the end of this session. If you have understood its contents, you should be able to find the number of intersection points of a circle and a straight line by finding the discriminant of the resulting quadratic equation. Thank you very much for listening. If you would like to understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.